What is the shape of PCl5 molecule and why is this shape and not any other? Now in order to deduce the shape of the PCl5 molecule, we have to deduce it according to the VSE PR theory, which is also known as the valence shell electron pair repulsion theory. In the PCl5 molecule, the total VSCP or the valence shell electron pairs around the central atom phosphorus is equal to 5, and also the central atom, which is the phosphorus atom, is sp3 dehybridized. So once it is sp3 hybridization, therefore in this hybridization 1s, 3p and 1d orbital of the same energy level of almost equal energy are involved in forming 5 sp3 dehybridized orbitals. So there is actually 5 sp3d hybridized orbital. Now how are these 5 sp3 hybridized orbital formed? Phosphorus with atomic number 15 has a configuration like this: 1s2, 2s2, 2p6, 3s2, 3p3. So this can be arranged in the electron box model as follows. So you have a 1s out here, then you have a 2s, then you have the 2p, next you have the 3s, then you have the 3p, and lastly you have the vacant 3d of the same level. So this is the vacant 3d. So we can say that this 3s, the 3p orbitals out here and one 3d, they overlap to give rise to 5 sp3d hybridized orbitals. Now as soon the 5 sp3 hybridized orbitals are formed, we have so phosphorus sp3 hybridized state, we have such 5 sp3d hybridized orbitals. If I am showing only the valence and or the outermost level, so 1, 2, 3, 4 and 5. So this is one sp3d, one sp3d, and also there are a total of 5 electrons to be distributed, and these electrons take the place like this. So one electron from this 3s level is excited and it is put up in the vacant d orbital, and so there are 5 electrons in a total of 5 sp3d hybridized orbitals. These 5 sp3d hybridized orbital can form 5 bonds with the chlorine atom, giving rise to 5 bond pairs and 0 lone pairs. Now these hybrid orbitals are oriented towards the corners of a trigonal bipyramid, in a sense that 3 orbitals form a plane are directed towards the corner of an equilateral triangle having their angle of inclination 120 degree, and the other two oriented at right angles to the plane of the triangle above and below it. Therefore, it is also known as a trigonal pyramidal hybridization. So if we draw the trigonal bipyramidal hybridized molecule, or the trigonal bipyramid structure, it will be like this. So these three chlorine atoms takes the corners of a triangle or equilateral triangle having their angle of inclination 120 degree, and one chlorine atom is above the plane of this triangle and one is below. So this particular orientation is known as a trigonal bipyramid structure. So this structure is there because there are 5 bond pairs to be distributed around the central phosphorus atom, and to minimize the bond pair repulsions that are present in these 5 bond pairs, the molecule of PCl5 takes the shape of that of a trigonal bipyramid. Other examples of a trigonal bipyramid or a TBP structure are PF5. So PF5 can also have a trigonal bipyramid structure.